I am Anil Kumar, sharing with you my passion of mathematics. Welcome to my YouTube channel where we have more than 20,000 videos and the website where you can find the latest updates. In this video, we'll learn about the distributive property. Now, as you know, I normally connect mathematics with real life. And so the question here is, why should we learn distributive property? So that is what you are going to understand in this particular video. We'll take up many real life situations and then you will see how distributive property is everyday math for us. What is its importance and significance? Learning really is connecting with what we do. And so, connect and learn. That's the beauty. You can always contact me on the address given to learn directly from me. Now, as we're talking about distributive property, there are many situations where you use it. But basic concept here is, should we multiply and add the things? Or should we first add the things and then multiply? You get the relation between the two. That is where the distributive property comes in. For example, if I have to find the area of this particular rectangle, I could divide it into some pieces as shown here and do this product x times x plus 3. So one way is to multiply x with both x plus 3. The other way is individually multiply them and add them up to get the result x squared plus 3x. You see that. So x squared plus 3x. So you see how distributive property can be visualized. Now this we have taken in one of our videos. Here also we'll take a few examples. However, our focus is more on the word problems, since word problem is also kind of tricky sometimes, right? So we'll take up situations like find area when length of rectangle is 5 more than width, total ticket cost for a group of students and teachers, count money from number of dimes and quarters, find total amount after investing at a fixed rate, and find calories burned by everyday exercise, right? So these calculations we normally do. Now, how do we interpret them and give a meaning, a quantitative meaning to these things is what we are going to learn in this particular video. I hope you find it interesting. So, just answering questions is one part. The other part is to understand the significance and enjoy the journey of learning, which you can do with me right now, correct? Okay, so let's hear once again the 4 questions which we are going to look into are: find area when length of rectangle is 5 more than width, total ticket cost for a group of students and teachers, count money from number of dimes and quarters, find total amount after investing at a fixed rate, and find calories burned per week from distance of walking. I made it 5. And basic distributive property is something like this: A times sum of so many things could be written as A times B plus A times C plus A times D and so on, right? So it's your choice, find sum of products or product with sum. Perfect. So that is what we are going to see as we move along in this particular video with different examples. So the very first one, as you can see here, is relating to find the area when the length of the rectangle is 5 more. So the question here is, write an expression to find area of a rectangle if length of rectangle is 5 more than width. Sketch diagram to illustrate solution. calculate area for width of 7 centimeters. So it's a complete package in itself, learning all the concepts. So let's make a rectangle, and we are saying that we have a rectangle whose length is related with the width, right? So if the width is W, then what are we saying? Write an expression to find area of rectangle if length of rectangle is 5 more than width, right? So width plus 5. 5 more than width is the length. So we can visualize that if the width is this much, correct? So on the diagram, it will form this particular square, right? So you can think this is like width and this is 5 more. You get the idea, right? 5 more than the width. So we have sketched a diagram to illustrate our solution. We're going to illustrate the solution just now, but to represent the situation, we have made a diagram, correct? So now we have to write an expression for area. As you know, area is product of length and width, right? Area is length times width. And in our case, we say that length is W plus 5, right? And the width is W. So we kind of have a product here, right? We are multiplying two expressions, W plus 5 with W. So how do we do that? Well, we can distribute and then get the result. So this is the product. As you can see here, this is what we are calling as product, right? Product of width with length, right? Now look here, let me rewrite this. So if I multiply individually both with W, what do I get? So what I'm trying to say here is multiplying W with W and then with 5, correct? So we could write this area also as W times W plus 5 times W. You get the idea. So now we are multiplying and then adding them. You see the two things, correct? That is what distributive property is, and what we get here is W square plus 5W. Perfect. Now from the model also, you know, the area of this rectangle is the block shown here, where how much is this area? Well, W times W gives me W square, right? So this area here is W square. And how about this? 5 times W is 5W. So you can see from this model that I could add these two things. So you can visualize what we are trying to do, right? So distributive property, now you can understand, is product of A with few things which are added, right? And what you really get is sum of their products. Do you see that? So what you really get is sum of their products, and that is what distributive property is. Is that clear to you? Correct? So that is how we are going to do it. And now, many times what we do is we have to evaluate, right? Get the area as a number also. So we have the second part of it, which is calculate area for width of 7 centimeters. So basically, we have the same rectangle here, right? Okay, and what we did was we kind of had, this is width and this is width plus 5, right? But now we are given that the width is equal to 7. Now we need to calculate the area. So basically you could say that we are multiplying 7 with 7 plus 5. You get the idea, because the other side now will be 7 plus 5. So you can, as I said, do it in two different ways. You could multiply 7 with 7 plus 5, which is 12, right? And what do you get? You get 7 times 2, 14, 4, 1, and 7 times 1 and 1, 84, right? Or What you could do here is multiply individually with 7 both the things. So you get 7 times 7 plus 7 times 5, right? 7 times 7 is 49 plus 35. And when you add them, you again get 84. And definitely the units are centimeters square because we have 7 centimeter length of width. You get an idea. So that is how the distributive property works. So in general, once again, let's focus on this. A times everything in the bracket which is added together. The A can be distributed and you can find these products, correct? And then add them up as shown here. That is what distributive property is, right? So I hope you got the whole concept with this particular example, correct? So I hope this concept is absolutely clear, right? Now let's just connect this concept with many other examples. So here is one practical application, right? Everyday life, we are going for some parties, picnics, right? And for recreation. So here is a situation. A group of 10 children and 2 teachers are going for fun rides. Admission tickets for each person is provided. Explain 2 ways of calculating the total cost of admission for the group. So we have a group which has 10 children and 2 teachers. Since there is a group, this is the cost provided to us, the group rates will be applied. So individual will now be charged $5 each, right? So how can you calculate this particular cost? And we need to explain 2 ways of doing it. So let's try to understand these 2 ways, right? So one is we have 10 children, right? So 10 children, each will be charged $5 and so it will be $50, correct? So that is the rate in dollars, correct? And then we have 2 teachers, right? Each will be charged $5 and so 2 times 5 is 10. And we can add them up and we get a rate of $60, clear? So that is definitely one way of doing it. So what could be the other way? So let's look into the distributive property, right? So the other way is, we know that the rate for every individual is just $5, right? So we can have this rate of $5 and put all the individuals inside, right? So we have 10 children plus 2 teachers, correct? So that becomes a sort of product, right? We are multiplying 5 with the sum of 10 and 2. So we see how we could do it. We have now 2 ways. We could multiply 5 with 10, right? And then add 5 times 2. So we get 50 plus 10 and the same result 60, right? So we pay $60. Does it make sense to you? So we could do the either way. So we could individually find how much are we paying for each children and teachers, add them up, right? And get the value. So product and then add. Or what we could do here is, look here, we could do 5 times within the bracket, it is 10 plus 2, right? So which is 12. So we can say 5 times 12 is 60. So we could do that also. Do you see that? So there are definitely many ways of doing it. Now here you see how the distributive property works, correct? So I hope you're appreciating it. Now let's take up more examples. Question number 3 here is financial application. Count money. I have equal number of dimes and nickels and quarters. Find the amount of total money if there are 12 coins. So I have 12 coins. So this is kind of tricky. So I've got 12 coins. Okay. Now these coins are of 3 types. One is dimes. I'm just making circles here for dimes means 10 cents, right? And then nickels means 5 cents. Okay, let me write this. And then we have quarters, which is 25. Okay. So equal amount definitely means that we have 4 of each, right? So we have 4 of each. Okay. Then we get total 12 coins. Makes sense, correct? Now the question is, find the amount of total money if there are 12 coins. We have to find the amount, right? So 4 dimes, let me write D for dimes, N for nickel, and Q for quarters, right? So you can see that we have 12 coins in all, 4 dimes, 4 nickels, and 4 quarters. We have to calculate the money now. So how you could do all these, the currencies in cents, right? See, cents. So what you could do here is you could multiply individually, right? So you can say, well, let's calculate. 4 times 10 gives us 40. 4 times 5 gives us 20. 4 times 25 gives us 100, right? And when you add this up, what do you get? We get 160 cents, right? Correct. This is one way of doing it, for sure. This is one way of doing it. Now, what could be the other way of doing it? The other way of doing this is that we could add the amount, right, of dimes, nickels, and quarters and multiply by 4. Does that make sense? Oh, shall we check it? Let's do it, right? So what we could do, since we have 4 of each kind, so we have this group, and the value is 10 plus 5 plus 25, correct? So we could add them first, right? Inside the bracket, operations are done, right? 25 plus 5 is 30 and 10 is 40, correct? And 40 times 4 is 160, correct? So we get 160 cents. Same amount. Do you see that? So 2 different ways of doing it. One, we added the product to get the amount, 160 cents. And in the other case, we applied the distributive property, correct? So what we are doing is, in the brackets, we put them, right, and then do it. So again, we saw a situation where we could write like product with sum, right? And you see, this is that addition which gave us a result, but the other result could be you could first add and then multiply. So both ways it works. Do you see that? Okay. So let's change this situation a bit. And talking about dimes, I'm just writing a next problem for you. I have added 3 dimes to a pile of dimes, right? So I have these dimes, right? So for example, we have these dimes, right? And what I did is on these dimes, I have added 3 dimes. So I have added 3 dimes to a pile of dimes, model value of dimes with distributive property. So I already have, let's say, D dimes, right? So D dimes are there and I added 3. Do you see that? And now model value, each dime is how many cents? 10 cents, right? So that becomes the value. Do you see the value? So we say value is that much amount. So 10 times D plus 3. So you see now we have used this distributive property. We can say now the value could be 10D, right, plus 30. In cents, of course, correct. Okay. So we are saying model value of dimes. So this is the value of dimes with distributive property. We have done that modeling with distributive property. How much money do I have now if there are 9 dimes? So I'm now working out with values. So if I have 9 dimes, so that means if capital D, which I wrote here, is equal to 9, then how much value does it have? What is the value, right? So that means basically I'm saying 10, 9 plus 3. Do you see that? So I could now do 10 times 12, right? And get 120 cents as one answer, right? The other way was using the distributive property, which is now we have 9, right? So we get 10 times 9 here plus 30. Do you see? And this is 90 plus 30. Which is also 120 cents. Make sense? So, back and forth, we can use this property very easily. Sometimes it is convenient to add and then multiply, and sometimes it is better to add the products. It gives us the flexibility, as you can see, perfect. But, well, the important thing is there are so many situations where we are using distributive property. Coming to financial applications, investment is something very important to do, right, in daily life. So here is a problem related to investment. So we'll actually find the total amount after investing at a fixed rate. Amount invested grows with time. And that's why we say save, right, and invest. Okay. If principal P of $500 is invested at an interest rate R of 12% per annum, means per year, find total accumulated amount A after 3 years. So for some of the students, this could be a tricky problem at this stage. However, we have defined few terms. The amount which is invested is normally referred to as the principal amount, and we have defined a variable, capital P, for principal. And this principal is given to us as equal to 500. So amount invested is $500, correct. At interest rate R of 12%, interest rate is given to us as 12%. Now always convert interest rate to decimal values. So 12% means 12 over 100, which is 0.12. Now this interest rate is per year, per annum. So every year on the money which you invest, you get 12%. So this is kind of simple interest we are working on. Now it says find the total amount accumulated A, right, after 3 years. So after 3 years we'll get some interest. So we have the principal amount with us, right? And then on this interest will be earned, which is proportional to the amount invested, PRT, where T is in years. You get the formula, right? Now the beauty of this formula is that I could rearrange this formula itself, as we are talking about distributive property, right? It is the sum of two things, right? P and PRT. So why not just write P as common and we get 1 plus RT? Makes sense. Both are same things. You're trying to understand this, right? So what we have done is the reverse calculation here. So we are working the other way. So we are starting with the sum of two things, and we do notice there's something common, right, which is P here, right? So why not just multiply by that and take it common? So we could do it like this. You get the idea. Perfect. So P is the principal and that's the amount, right? So basically what I'm trying to say here is that one of our approach here in this particular is to, we just found that formula is P plus interest, right? Interest is PRT, right? And we also worked that this amount could also be written as P1 plus RT, right? So both ways it can work, and now let's see how it really works, right? So principal amount 500, correct? Plus we have 500 times rate of interest, we converted to 0.12, right? And then time is 3 years. This is one way to calculate. The other way is we could multiply the 1 plus 0.12, right, 12% times 3, which is duration. So we could do both these calculations to find our answer. You get the idea, right? So both will give us the same result. So that is what we're trying to say, right? So you could do this, right? So calculate, correct? So this is not very difficult to calculate. You could actually do 500 times 1 and 3 times this will be 0.36. Is it clear to you? And then multiply by 5, 2 zeros gone. 5 times 6, 30, 3. 5 times 3, 15, and 3, 18, 8. And 5 times 1 is 5, and then 680. So you get $680. That becomes the amount, correct? I'd like you to do this calculation also and see, do you get the same amount, correct? So that's what it is. And now, what we are really seeing here is that there are so many applications, right? Not just one or two, right? There are so many applications where distributive property can be utilized. Makes sense, right? So that is the financial application. And now let's take up a real life situation, everyday walk, right? Exercise, good for health. Question number 5 here is find the calories burnt per week from distance of walking, right? Let's say the question here is Anil burns approximately 150 calories per hour by walking. The table below shows the time he walked last week. So these are the 7 days of the week, and the time recorded was 1 hour on Monday, 1.5 hours on Tuesdays, 1 hour Wednesday, 1.5 hours Thursday, 2 hours Friday, 1 hour Saturday, and resting on Sunday. Making this video for you, right? Okay, great. So now the question here is how much energy, rather calories, were burned, right? Now this I have taken 150 calories. Depends really on how fast you walk, right? If you kind of walk with the speed of 5 kilometers an hour, this is the amount of calories you can burn. Okay, great. Good information. So now, what we could do, how do we find the calories burned? So we know we are burning at the rate of 150 calories per hour, right? So 150 in 1 hour. So Monday I burned 150, that means, correct? So, and on Tuesday, how many calories I am going to burn? So 150 and half of 150 is 75, right? So I'll add 150 and half of 150, 1.5 you get, right? So we get 225. Makes sense, right? So, okay, so 225 here. So 1.5 square is also 225. So it is correct. You get the idea. How to work with numbers is also very important thing, right? Okay, 225 calories, and this is 150. Okay, and one, I know I calculated. Twice is 300. Great job. And this one is again we burn 150 and 0 calories. So what I've done here is that I have multiplied each with 150, and so I know this is the total calories burned, right? So we can find total, right? So total will be add them all, correct? So we have 150 plus 225 plus 150 plus 225 plus 300 plus 150, right? You could do all that, get your result, total calories burned, perfect. Easily, you can do this, right? Now you can see how cumbersome it is to multiply each and every number and add those calories, correct? Now how does this distributive property help us? Okay, let's see this situation once again. So what we are saying here is that total calories burned is 150 calories per hour, right? Why not add the hours, right? Instead of adding those things. So add the hours and multiply with calories. So what do we get now? We know we have 150 per hour. So add these hours. 1 plus 1.5 plus 1 plus 1.5 plus 2, right? Plus 1. Well, plus 0. Okay. Now, you see, it is easier to add these smaller numbers. It is easier. You can see for yourself, right? Becomes much simpler, right? Now, we have to just add these numbers, right? So, 1, 1.5, 1, 1.5, 2 and 1. Simple. 1 and 1.5 makes this 2.5. This is 3.5, 4.5 and 0.5, 6, 7 and 8, right? Makes sense. So, what we have done here is we added the smaller numbers first and then multiplied by 150, and that's what we will do in everyday life, right? That's distributive property, right? So when you do this multiplication, 8 times 0 is 0, 8 times 5 is 40, and 8 times 1, 8 plus 4, 12. So 1200 calories burned. You see that? So we burned 1200 calories. Don't you realize this is a much simpler way of doing, right? Then what we just did, right? We added the big numbers, right? So now you understand You could multiply with the sum or you can add the sums together. That is distributive property. Now it is all up to you what you really want to do. So this particular technique which we have learned today, which we are saying distributive property, you see in how many situations we have applied it. Beautiful, isn't it? So I hope you like to learn more math concepts and apply them in daily life. And that is why we just, began with this chapter in the first place. In my playlist, you'll not only see such examples and beautiful illustrations, which gives you visual presentations, but practical things like how do you use the concepts learned, right? Connecting concepts with the situations. Perfect. I hope you understand and appreciate it. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.